Hello friends, myself R.D. Mahajan presenting my video on the topic separation of real and imaginary parts of circular and hyperbolic function. First example, separate real and imaginary parts of sine of x plus iy. Therefore, to separate it into real and imaginary part, we have to expand that function. Therefore, that given function is sine of x plus iy. We expand it by the formula sine a plus b. Its expansion is sine a cos b plus cos a sine b, and as per that it is sine x cos of iy plus cos x sine of iy. And here we have to apply that standard results, whatever we have studied in earlier section. We know that sine of iy is I sine hy, and cos of iy is cos hy, a relation between circular and hyperbolic function. And therefore this I will replace cos iy as cos hy, and this sin iy I will replace by I sin hy, keeping other terms as it is, and therefore we get it is equals to sin x as it is into cos hy plus cos x as it is into I sin hy, and therefore we can rewrite this as sin x into cos hy plus I times sin hy into cos x. Therefore, first part is the real part and the second part is the imaginary part. Therefore, this is the separation. Therefore, sin x cos hy is the real part and sin hy cos x is the imaginary part of that function sine of x plus iy. If here we have minus, we get here it is minus, we get here minus, minus, minus. Okay. Another example. Then second example, separate into real and imaginary parts of cos of x plus iy or cos of x minus iy. Therefore, first of all we consider x plus iy, cos a plus b. Its expansion is cos a cos b minus sin a sin b, and as per that this cos x plus iy I can rewrite as cos a cos b, means cos x cos of iy minus sin x into sin of iy. Once again converting this using this relation, cos iy is cos hy and sin iy is I sin hy, keeping other terms as it is. and therefore it is cos x into cos hy minus sin x into I sin hy, and therefore the first term is a real term. Cos x cos hy is a real term without I means, and minus I times sin hy into sin x. Therefore the first term is the real part and the second term is the imaginary part of that function x plus iy. And when we have a minus here we get plus. Okay. Next example, separate into real and imaginary parts of tan of x plus iy. Therefore here given is tan of x plus iy, and to separate it into its real and imaginary part we rewrite that tan as sine upon cos. Therefore sine of x plus iy divided by cos of x plus iy. Then to simplify it further, we multiply and divide by the conjugate of this term. Its conjugate is cos of x minus iy and divided by same term cos of x minus iy. Then multiplying and dividing by 2 we get 2 times, and dividing by 2 it is 2 times sine of x plus iy cos of x minus iy and divided by 2 times cos of x plus iy into cos of x minus iy. And then applying the standard trigonometric formulas, we know that 2 sin a cos b sin a cos b as sin a plus b plus sin of a minus b. And second result, 2 cos a cos b as cos a plus b plus cos of a minus b. Applying this result, we get here a is x plus iy and b is x minus iy. Therefore sin of a plus b, sin of x plus iy plus x minus iy, plus iy minus iy get cancelled, we get sin of 2x plus sin of a minus b, this minus this, x get cancelled, iy plus iy we get 2iy divided by applying this to cos a cos b as cos a plus b plus cos a minus b, and therefore it becomes cos of a plus b, again the addition of these two, as cos of 2x plus cos of a minus b cos of 2iy, and then it is equals to sin of iy is I sin hy, and therefore it is sin 2x as it is plus I times sin h 2y divided by cos 2x, and cos iy is cos hy, and therefore it is cos h 2y. Taking separate division, we get the real part as sin 2x divided by cos of 2x plus cos h 2y as a real part, plus I times imaginary part is sin h 2y divided by cos 2x plus cos h 2y. Therefore, this is the real part and this is the imaginary part of tan of x plus iy. Fourth example, separate into real and imaginary parts of cosec of x plus iy. Therefore, this given cosec x plus iy we can rewrite as 1 upon sine of x plus iy. Then to simplify it, we multiply and divide by its conjugate. The conjugate is here sine of x minus iy, and we divide by the same number sine of x minus iy. Okay, then it is equals to sine of x minus iy divided by sine of x plus iy and sine of x minus iy. We multiply and divide by 2. Therefore, here it is 2 times sine of x minus iy and divide by 2 times sine of x plus iy, sine of x minus iy. Then it is equals to 2 as it is. Sine a minus b, using that expansion, sine a cos b minus cos a sine b. Therefore, sine a cos b minus cos a sine b, and therefore expansion is sin x cos of iy minus cos x sin of iy. And standard trigonometric formula, 2 sin a sin b is cos a minus b minus cos a plus b. Cos of a minus b, this minus this, x cancel. Iy plus iy, we get 2iy, and minus cos of a plus b, addition of this 2 is cos of 2x, and therefore it is equals to 2 times sin x. We know that cos of iy is cos h y minus sin of iy is I sin h y cos x as it is. Again, cos iy is cos hyperbolic 2y minus cos of 2x, and therefore taking separate division, we get the real part as 2 times sin x cos hy divided by cos h2y minus cos 2x as a real part, and minus I times 2 times sin hy cos x divided by cos h2y minus cos of 2x. Therefore, first bracket is the real term, therefore real part, and second bracket represents the imaginary part of cosec of x plus iy. Like this, we can separate the given function into its real and imaginary part. In my next video, I will discuss some more problems of separation of real and imaginary parts of circular and hyperbolic function. Therefore, if you are watching my videos, please like and share it, as well as subscribe to my channel for new videos. Thank you very much.